Swayam Prabha. Digital India. Educated India.
So, now that we understand the concepts of average treatment effect and average treatment on the treated, what we would try to do next is to understand how this can be actually related to a regression framework. So, in other words, when you run a regression of x on y, what is the treatment effect and how do you get to the treatment effect in a regression framework. So, to understand this, let us get back to our original definition of this the observed y I that you have, which is essentially the y naught I, which is the initial baseline level of outcome, and then the difference between the final outcome y 1 I and y naught I, the initial outcome, which if you recall we had discussed that this is the treatment effect. So, what you can do is you can rewrite this equation just by adding a few terms, particularly over here. As you see, what we have done is we have subtracted the expectation y naught I and then we have added the same term again. So, this is just a simple manipulation over here, and what you can see over here, right, in this particular equation, this now reflects the standard regression model. So, that your y naught I minus y expectation of y naught I is essentially the difference between the expected value and the observed value, and hence is summarized in the error term. The expectation of the baseline value of y naught I is essentially the intercept in your regression, and then the y 1 I minus y naught I, which is the treatment effect, is captured in the coefficient of d I, which is beta. So, now you see the analogy between the treatment effect that we discussed or we defined in the previous slides and a regression framework. So, how do you prove that beta is indeed the treatment effect? So, what you would do is you would first compare the outcomes between treatment and control. Now, if you recall, once again the treatment group is d I equal to 1. So, what you would be doing is you would be taking the average outcome for the treatment group, which is expectation of y given d I equal to 1, and then substitute in the regression equation that we have already that we just derived above, and see what happens. What we get is when we put d I equal to 1, we just get alpha plus beta, because you are putting d I equal to 1 over here, and then the expectation of the error given that d I equal to 1. Next, what you would do is you would do the same thing for the control group. You take the expectation of y I given d I equal to 0. So, once again you substitute d I equal to 0 in the equation that we just saw, and what you get is alpha as before. But now remember, because d I equal to 0, this whole term of beta d I goes to 0. What you end up with is the expectation of epsilon I given d I equal to 0. So, then once you take the difference, if you recall that the treatment effect is nothing but the expectation of y I given d I equal to 1 minus expectation of y I given d I equal to 0, which is the expected value or the average value of the outcome, which is y I, between the treatment group and the control group. So, that is the observed difference between the treatment and the control group is this difference over here, and that leads you to, when you take the difference between these two terms, to beta plus the difference between the error terms in the control group and the treatment group. Now, once again see the analogy between what we discussed before. This beta is the true treatment effect, and this additional term that you have, which is any difference in the error term between the treatment group and the control group, gives you the selection bias. Okay. So, then this is the selection bias, and what this tells you is the correlation between the treatment dummy and the random error. This is essentially once again going back to what we were discussing before, it reflects the differences in potential outcomes, the initial outcomes even before treatment happened between the treatment group and the control group. Now, when in a randomized setting, what you should have is ideally you should not have any difference between the treatment and the control group, and remember that is exactly what our counterfactual was, that you should be comparing apples to apples, but then when you have this inherent differences between the two group, which is captured in the term in the selection bias, then you cannot fruitfully compare the two groups and arrive at a causal estimate. What you would be having is, you have the true causal estimate beta plus the selection bias, and you do not know whether this selection bias is going in the upward direction or downward direction, and you have a confused estimate which you end up saying or treating as the correlation between y and x simply, and not the causal relationship. So, how do we actually prove that this estimate of beta, if we had a randomized setting, a randomized experiment, let us say, where y naught I is independent of di, how do we actually show that the beta is indeed the true estimate or the unbiased estimate of the treatment effect? Now, there are multiple ways of deriving this, but what we would do in this course is just try to understand the intuition by which this derivation can be arrived at. So, what we have over here is first think of the OLS estimate of the yi given di equal to 0. Now, the OLS estimate of yi given di equal to 0 is essentially the alpha term, and so the OLS estimate of the intercept is the consistent estimator of expectation y given d equal to 0. Similarly, when you take the OLS estimate of the treatment group, which is expectation yi given di equal to 1, what you arrive at is alpha plus beta. Because remember, with a randomized experiment, your selection bias tends to 0, because your error term, the expectation of the error term is independent of di by construction of an experiment due to a randomized setting, and then what you have is the expectation of yi given di equal to 1 minus expectation of yi given di equal to 0 is essentially the treatment effect or the average treatment effect that we are interested in, and that is equivalent to beta, as you can see over here from the derivation. So, what it means is very nice in the end. It just means that you can run a regression, and given that you have satisfied the randomized or the independence, the conditional independence assumption between the epsilon I and the di, what you arrive at in that coefficient beta is actually capturing the average treatment effect. Okay. So, the approach easily generalizes to where d is not binary, which is again an improvement over the framework that we saw earlier, where you are taking the mean difference between the treatment group and the control group, because then you have to say that the treatment and control is a dummy variable, which is a binary variable. So, what you have is the expected value of yi in the treatment group, the expected value of yi in the control group, and you take the difference between the two. So, in that case your treatment has to be a dummy, a binary, but in a regression framework, remember, you can have a continuous treatment, in the sense that you can have different intensities of treatment and you are still able to get the treatment effect or interpret beta as a treatment effect for depending on the situation or for every unit of treatment, and that unit of treatment need not be a movement from 0 to 1, it could just be a small infinitesimal increase in the treatment or a decrease in the treatment. Another benefit of a regression approach is that when you are comparing the treatment effect or the outcomes between the treatment group and the control group, you just have a mean difference. Now, you do not know whether this is statistically significant or not. So, you have to consider the standard error or the inference techniques. Now, in a regression framework, you can read the standard error readily out of the regression, because regression also includes the estimation of the standard error. So, you have the whole setting without going into the differences between the two groups, you can just look at the regression coefficient, see whether it is significant and say whether the treatment effect is positive or negative and whether it is significant or not. So, now that we have discussed and we have defined the average treatment effect in an experimental setting, which is basically saying that we create or we set up an experiment to be able to arrive at the assumption or make sure that the assumption of the conditional independence actually holds. What we would do next is we would try to take specific examples in the literature, experimental examples where people have actually gone into different types of experiments to answer different questions and try to see how these different assumptions unfold. So, just to give you an example, a few examples actually, there of very important experiments run in economics. So, one of the very early experiments was this Perry preschool program, a Head Start program in the US. So, essentially what it involves is, it involved a group of about 123 children who were followed for a long period of time, and the experiment was such that at that time there was a policy concern in education that whether a preschool program, that is an education program before you even start schooling, whether that helps you learn better when you actually finally enroll in school. Now, of course, this is expensive because you have to provide teachers, you have to provide learning material, a school setup, etc. So, it is not clear whether the government should spend a lot of money on these programs if you do not know a priori whether these programs are beneficial for the students and how beneficial these are for children to learn in the future. So, what they did was this small experiment, very neatly constructed, where they took about 120 children and they placed them in a treatment group and a control group. Now, the treatment group was where they had a preschool program, a Head Start preschool program, and the control group was where they did not have a Head Start preschool program, which is an education program before you start schooling. And what they did was they were trying to capture the difference in how these two groups evolved over time, and there have been many studies which analyze this particular program, this particular experiment, and what they find overwhelmingly is a support for the Head Start program. And based on these evidences, in fact, the US government spent a lot of money later to publicly provide Head Start programs. Now, what we are going to look at, and then there are other experiments, for instance, this again a very important experiment, the STAR experiment, which looks at the effect of class size on learning of children. We are going to take this up in details, this full paper, and then another example that I have shown you before, performance pay, whether fixed pay is better than performance pay or vice versa. So, there have also been experiments run on that. So, these are all in the international context. When we come to India, once again there are a lot of experiments that are happening in education, in marketing programs. So, one of the very well known programs is this Bal Sakhi program, where teaching assistance was given to disadvantaged students in school, and the idea was that with personal teaching assistance or computer assisted learning. So, they have tried various types of treatments, children would learn better. And in fact, once again this paper by Banerjee and Duflo, they find a positive impact of providing teaching assistance to students. What we would take up in the context of India is one paper which tries to find out the how to market insurance products. A particular insurance product that they consider in their paper is a rainfall insurance, and we are going to see how that experiment unfolds. Now, before we move on to this specific paper on rainfall insurance, a few things that we need to consider is in the context of randomized experiments, one of the most important assumptions that we have already discussed is the conditional independence assumption, that y naught I should be independent of d I. Now, how do you actually go about proving this or making sure that this holds? Okay. So, one way of saying this is that a successful randomization implies balanced characteristics across the treatment groups or across the treatment and the control groups. Now, what this means is that suppose you are suppose you take this experiment, what is the impact of class size on student learning. Now, even before you put students in large or small classrooms, you need to know that the kind of students that you have or the treatment and control group have the same y naught I. Now, what is y naught I? When you are interested in a question of class size on outcome, on learning outcome, your y naught I is essentially the learning outcome even before you have treated the students. So, what you would be taking is possibly you would run a test even before you actually start schooling to see how the students are placed in terms of their cognitive ability between your treatment, the small class and the large class. So, what you would have is a measure of y, your variable of interest or your final outcome of interest even before the experiment started, right. So, important condition is that y naught I must be independent of d I. So, another way, and these are actually just different ways of saying the same thing, is that every I or every unit of observation in your data should have the same probability of treatment. In other words, they should have the same probability of either being assigned to the treatment group or being assigned to the control group. And so, once again, this is again saying the same conditional independence assumption in a different way. And how do you ensure? So, suppose the example that I gave you, which is class the test scores even before you actually run the experiment, there you can run a test, but not every time do you have the possibility of observing y naught I even before the experiment has happened. So, for instance, in the case of, suppose you are trying to market a particular product, in this case the rainfall insurance. Now, it is very difficult to and there your outcome variable that you would be interested in is what is the take up rate. Once you market the insurance product, do people purchase the insurance product? It is more difficult to think of a purchase rate even before you have instituted the experiment. So, in those cases where you do not have observations on y naught I, another way to prove this conditional independence assumption is that you would be comparing the pre-treatment outcomes or other covariates across the treatment and the control group. Essentially, what this is saying is that in the case of the children going to school, going to small classroom or large classroom, you would be comparing children's characteristics like age or gender or maybe incomes of their families and so on, various kind of characteristics of these children who are placed in the treatment group and the control group, and try to see whether these characteristics are balanced across the treatment and the control groups. And that actually is a sort of a substitute for not being able to check the difference between y naught I in the treatment and the control group. So, in the absence, so once again, in the absence of y naught I, what you would be doing is you would be checking on x naught I between the or various x naught i's between the control and the treatment groups. So, let us take the example of this particular paper, Marketing Complex Financial Products in Emerging Markets, Evidence from Rainfall Insurance in India. So, in this paper, what the authors do is they look at various their main objective is to look at the effect of financial literacy program on insurance take up. Now, the idea is that with financial liberalization in emerging economies, we have had an influx of a lot of financial products, but what you see generally is that there is a slow adoption of these products. Now, it is not in it, when you look at economic theory, you can come up with various theoretical insights on why there might be a slow adoption. But the point is that, so for instance, you could you could say that there is a lack of experience with financial products in these underdeveloped markets, and hence people do not know about financial products. The other possibility is that people are price sensitive. So, these financial products are have a high price which people do not want to pay for. And yet another possibility is that there is no financial literacy. People do not understand the importance of financial products to begin with. Now, of course, theoretically you can have various insights about why there is a slow adoption, but when a company tries to actually market the product and tries to make it a profitable enterprise for itself, it needs to know the exact reason why people are not buying their insurance products, because unless it knows the exact reason, it will not be able to address that problem. Okay? Hence, you need to do an empirical study to understand which of these theories is at play. So, in their paper, in this paper that we are discussing over here, Gaurav et al. 2011, which was published in JMR, Journal of Marketing Research, what they do is they offer rainfall insurance and financial literacy program to about 600 small scale farmers in India. The effect of the financial literacy training and 6 marketing treatments are evaluated using a randomized control trial. So, what they do is in addition to the financial literacy program that they give out to people, that they assign people to, they also have 6 different marketing treatments to understand which of these is actually going wrong, where can they improve to improve adoption of these this particular rainfall insurance product by people. So, the motivation for this study comes from the fact that in most developing countries, risk management is primarily informal. So, there are informal techniques available like crop diversification. So, because people might be affected by weather or high rainfall in one particular type of crop and their entire income would go down, people diversify across crops. Sometimes they would depend on family and relatives for credit in the case of adverse shocks. Sometimes they depend on social institutions. So, social institutions here mean, once again, it could mean the credit network given not only by your families and friends and relatives, but also by money lenders in the villages and so on. So, typically in the absence of formal credit markets and formal ways of coping with risk, people fall back on these informal mechanisms to cope with risk. However, imagine a weather related shock. So, when a full village faces a weather related shock, typically these shocks are correlated. What does it mean? That most of the villagers in a particular village depend on the same agricultural income, in the sense that they have the same source of agricultural income. They might all be planting the same crops in the same village given the terrain and the weather. So, when hit by a bad weather, everyone in the village suffers, everyone experiences a fall of income. And because weather shocks are correlated and everyone experiences a fall of income, what that means is that you would find it difficult to insure yourself against this adverse shock when you look to other friends and family members and relatives in your village, because everyone else has also experienced a fall in income. So, without formal mechanisms to manage weather related risks, agricultural households may invest less, not adopt profitable farming innovations, and may have less access to credit. So, what you need to counter these adverse weather shocks is a formal way of addressing them, maybe a formal insurance mechanism that we are talking about. And of course, given these adverse weather shocks which are correlated, farmers would benefit from the adoption of rainfall insurance. So, if they do benefit from the adoption of rainfall insurance, the question is, why do they still not adopt? So, as we discussed, one of the reasons could be that they are price sensitive. So, these rainfall insurances are just too expensive for them. Another reason could be that they do not understand insurance products, which is actually one of the most common examples that you find across all insurance products. What people think is that they are spending money to buy the insurance product, but suppose everything goes well. So, there is no adverse weather shock. When you think of health insurance products, it is the same thing, there is no adverse health shock, people do not get back their money, they do not get back anything. you get a disbursal or a reimbursement only in the case that you have been affected by an adverse weather shock. So, for people to understand that they are giving money, but not getting anything in return in most of the times when the weather is good, is difficult for people to understand, and they do end up not buying the insurance product. So, what the authors do in this paper is they design a field experiment to test whether financial education and marketing can increase purchase of rainfall insurance. So, particularly what they do is they choose these 3 districts of Gujarat, which are coastal districts, and which are all rain fed, and most of these districts actually or predominantly produce groundnut, what they do is they select 600 farmers from these 3 districts of Gujarat and make them part of the experiment. Now, the insurance product that they are selling to these farmers is a rainfall insurance, meaning that it is not linked to actual failure of crop, because there are also crop insurances, remember, but this is linked to the amount of rainfall. So, this is linked to weather, but not the actual failure of crops or not, because one of the reasons for doing this is that it is easier to understand that there is no moral hazard or no adverse selection when it comes to rainfall insurance as opposed to when it comes to crop insurance. Because suppose you have a crop failure even with a good rainfall, this could be because you have not put, as a farmer, you have not put enough effort to produce those crops. So, this is a new type of agricultural insurance, the weather insurance. And so, what they do is they choose 600 farmers and they divide them between the treatment group and the control group, which is one of the treatments here is financial literacy. So, they give a financial literacy training to some of these farmers, and but even before they actually proceed to the experiment, to institute the experiment, what they have is they conduct a survey comprising of household demographics, socioeconomic conditions, livelihood, financial awareness, and detailed farm and farmer related information. So, the reason for conducting this particular survey even before instituting the experiment is essentially, one of the purposes is to see that between the treatment group and the control group they have similar type of characteristics. So, this is again going back to the conditional independence assumption, the CIA, okay, and this will help you, more data would actually help you establish the CIA. Even when you do not have observation on Y naught I, what you would have is you would have observations on X naught I, and you would try to see whether this is independent of your treatment DI or not. So, what they also have is a financial literacy and a cognitive ability measured prior to the training. So, they want to ensure that the people to whom they are giving financial literacy, or people who are participating in the financial literacy program, they have the same financial initial financial literacy or initial levels of financial literacy and cognitive ability as the people who are not in the training program. So, this is the average, what you see over here in this table is this average sample characteristics. Of course, if you go back to the paper, you will find a longer table with many other characteristics, but over here we are just going to look at the most important ones and a subset of the table. So, what you see is that the sample is comprised primarily of males. So, about roughly 88% are males in the sample with an age of about 50 years. Average schooling is of 9 years in the sample, and 3.23 is the average land owned, 3.23 hectares is the average amount of land owned by people in the sample. The average household size of the participants in this particular experiment is 5.82, and the average monthly per capita expenditure, which is also a substitute or also a proxy for income, is 1500 rupees in the sample. Now, these are all standard deviations as you see in the right hand side column. So, given this sample, what they do is the intervention comprises of two parts. So, this is the most important slide in terms of how the experiment is designed. So, they provided, first part is they provide general lessons on financial management, savings, credit management, insurance with the help of charts and posters and pamphlets. So, this essentially comprises the financial literacy training. So, the idea is to understand whether people have financial literacy. So, they ask questions about their understanding of interest rates, compound interests, and their understanding of various insurance products. So this general understanding, and then lessons are provided on financial management, savings, credit management, etc. So, this comprises the financial literacy training. Now, the other what they do is they made them play a set of games enabling farmers to understand the role of insurance in protecting against covariate income shocks resulting from adverse weather conditions. So, what we were discussing before, that every farmer faces a correlated shock when they are all living in the same village. So, a module was given to them where they understand the implications of these correlated shocks. Then they were also of course told about the limitations of the insurance mechanism, so that they fully understand that this is not only the benefit, but there are also risks attached to an insurance product. And then they were told the frequency and severity of natural disasters. So, they have a sense of probability of being hit by a shock. And then there were also there was a discussion that included benefits and limitations of crop insurance and rainfall insurance schemes. Now, in addition to the financial literacy program, what the authors or the experimenters also introduced were 6 marketing interventions. So, what were these marketing interventions? The first one is the money back offer. So, as I told you, one of the reasons people do not theoretically people do not take up insurance products is they believe that once they have given out the premium or they have paid out the premium, in the case of a good weather condition, they do not get back anything. They do not get back any payout. They have just paid they have themselves paid for the premium for this insurance product, but they do not get back anything. So, one of the so to test this assumption or to test this particular hypothesis, what the authors did was they offered money back guarantee, which means that if you have paid an insurance premium and you have not been hit by a weather shock, then you are given back the premium that you had paid. The second intervention was weather forecast only, which is basically that the farmers who participated in this experiment and were in the treatment group, they were given out weather forecasts for that particular village. And then the third one is demo. Demo is essentially how the millimeters of rainfall that that a village receives is linked to the soil moisture, and in fact this is the metric on the basis of which the insurance company decides whether to give out or pay out insurance or not, because depending on how heavy a rainfall you have or how less a rainfall you have, that will determine your soil moisture and in turn determine the success of your crop or the failure of your crop. Now, in addition to these 3 standalone interventions, what they also have is a combination of these interventions, which is money back offer and weather forecast. So, all the possible combinations you can think of, then demo and weather forecast, and then money back offer, all 3 of them taken together, money back offer, weather forecasts and demo. So, so now what they do is they take 300 farmers, and so these are all randomly selected from this group of 600 farmers, and you put them in the literacy financial literacy education or training program, and the remaining 300 were not invited to the training program. So, remember what you are doing now is this random assignment. You have a group of 600 farmers, you pick each of them with the same probability and put them in the treatment group. So, every person over here, because it is 300, has equal probability of being in the treatment group and the control group. So, you pick 300, you put them in the treatment group where they receive financial literacy training, or they are supposed to receive financial literacy training, and the rest of the 300 are not supposed to receive financial literacy training. However, what happened is that, so this is what it is saying, the remaining 300 were not invited, but some of them did attend the financial literacy training. So, what this means is that even if you have put people in the treatment group and the control group, not everyone complies with that assignment of treatment. So, in the you can think of an analogy in medical trials, for instance. So, suppose I want to test the efficacy of a particular drug, and I give in a sample of 600 patients that I have, I give 300 of them a particular drug. These are randomly chosen patients out of the sample of 600, and the rest 300 do not get the drug. But I cannot force them to either have the drug or not have the drug. So, it is always possible that in the group of people I gave the drug to, some of them do not end up taking the drug, and the group of people I did not give the drug to, some of them end up taking the drug. So, there is non-compliance in both treatment and control groups. So, in this case, what we have in this particular experiment is that there were 300 people who were placed in the control group, that is not invited to the financial literacy training, but some of them in the control group still attended the financial literacy training finally. What this means in terms of randomization is that it actually invalidates the randomization that I have done, right, because I initially randomly pick people, put them in the treatment and control group, but then some of them do not comply with that assignment and actually end up getting the treatment when I have not assigned treatment, or end up being in control when I have assigned treatment. So, we have to think of ways to actually address this problem econometrically. Now, the second part is that 282 households were randomly selected for the marketing visits, and these 282 households received at least one of the 6 possible marketing treatments that you saw in the previous slide. So, this table shows you the division between the various types of treatments that we have. In the very first column, there is no marketing treatment, okay. And what you have over here is what you see within this group of no marketing treatments, you have 157 who were not invited to training, and 159 people who were, or farmers who were invited to training. So, this is the treatment group in terms of the financial literacy, and this is the control group in terms of the financial literacy. And then when we look at the money back treatment, we have 25 people who were within the money back treatment group. There were this just shows you that there were 47 people in the money back treatment group, and out of this 47, 25 were not invited to the financial literacy program, and 22 were invited to the financial literacy program. And similarly, what you can see is how the division happens between financial literacy and no financial literacy in all the marketing treatment groups. The numbers that you see in percentages in the brackets is essentially showing you how many of these people finally took up the insurance products. So, again, if you look at the very first column where there is no marketing treatment, what this means is that people who were given financial literacy training, of them 13.2% people took up the insurance product, and for people who were not given the financial literacy training in the control group, only 6.4% of them took up the insurance product. So, what you see is that there is a clearly, I mean, even in this very rough and raw data table, what you see is that more people took up the insurance product when they were included in the financial literacy training, compared to the situation when they were not included in the financial literacy training. So, given this description of the experiment, how the groups were assigned to different treatments, what we need to now check is the most important part, which is the random assignment itself. So, we need to check for randomization. which is, as I said, the CIA assumption, the conditional independence assumption, or that y naught I is independent of di, and given that we do not have y naught I, what we would be doing is we would be checking x naught I independent of di. What this means, in other words, is that x naught I, the average x naught I, the expected x naught I should be the same in given di equal to 1 and di equal to 0. So, remember what we had, the condition was that expectation of y naught I given di equal to 1 should be equal to the expectation of y naught I given di equal to 0. So, in the absence of y naught I, what we are going to check is with x naught I, which is the different covariates. So, balancing of covariates across the treatment and the control groups. And in this case, remember, so right now we would focus on the financial literacy intervention. So, the treatment group is people who were invited to the financial literacy intervention, and control was people who were not invited to the financial literacy intervention. So, random assignment facilitates the measurement of causal impact of training on rainfall insurance take up. So, because if the CIA assumption, so if the random assignment holds, only then can you drive the selection bias to 0. So, in the next table, what we have over here is the average characteristics, all these different characteristics across the treatment and the control group in terms of financial literacy intervention only. Because we remember we have 6 other interventions, but right now we are only focusing on the financial literacy intervention. So, what we see is that the average financial literacy between the treatment and the control group are very similar, in fact identical in this table, and there is no significant differences as is reflected in the p value between. So, for any level of significance at the 10% level even, there is no significant difference between the treatment and the control group in terms of initial financial literacy of these people. So, this is before the program was introduced, before the experiment was or before the financial literacy intervention or training was given. Once again, when you look at household size, very similar household sizes across the treatment and control group, very similar age, roughly 50 across the treatment and control group. Important to see is that none of these characteristics, whether it is household size or age or land holding, years of schooling, cognitive ability, gender, none of these are actually significantly different between the control and the treatment groups. Once again, we have measures of risk aversion. So, whether people are more risk averse in the control and treatment group, the reason that this variable is so important, risk aversion, is when you are purchasing an insurance product, it means that people who are more risk averse are more likely to purchase the insurance product, because they are worried that they might be hit by a negative shock, and people who are less risk averse are willing to take more risk and not buy an insurance product. So, it is very important to check whether the difference in purchase rates between the treatment and control group could be due to a difference in risk aversion between the treatment and control groups. And clearly, what we see over here is that the risk aversion measure is balanced between the two groups. So, the average risk aversion is the same in the treatment and the control group. What is slightly different between the treatment and the control group over here is the drought experience. It turns out that people who were invited to the financial literacy program had a lower probability of experiencing drought than the people who were not invited to the financial literacy training program, and this difference is significant at the 10% level. So, we will see what we can do about it later. So, similar to the financial literacy intervention, what the authors also do in the paper, if you go back to the paper, you will see they also have a similar table for each of the 6 experiments that 6 different marketing treatments that they conducted. So, they have a similar test of random assignment in the case of the marketing treatments. Overall, the only variable that turned out to be not balanced across the treatment and control groups was the drought experience. So, what they do is they first start by predicting financial literacy. So, what are the different variables that affects your financial literacy? So, this is even before, remember, the training actually happens. So, this is your overall financial literacy and how that is predicted by your age, cognitive ability, land holdings, which is also a proxy for your income, schooling, discount rate, which is again the risk aversion, and various other indicators or various other variables which are captured in XI. So, if you look at the results, what they have is that they find that financial literacy improves with age, it improves with cognitive ability, as you would imagine. People who are who have higher cognitive ability also have better financial literacy. It improves with land holding, although not much. Then people have lower financial literacy if they have a higher discount rate, which is if they have lower risk aversion, and then it also depends on the category. So, this is the OBC category, and they are they have lower financial literacy compared to SC/ST category in this case, which is the omitted category. And then years of schooling does not affect your financial literacy, and then again if you belong to the general caste as opposed to the scheduled caste or the scheduled tribe, then you have lower financial literacy. However, an important thing to note over here is that none of these coefficients that you see in this table are causal estimates. This is a simple correlation regression, because you have not randomly allocated any of these variables across treatment and control groups, and hence these are just correlations. So, now we turn to the actual experiment in this paper, the most important question, whether financial literacy increases insurance take up or whether it at all affects insurance take up. So, what you have over here is this invited to training, which is a random assignment, whether you were invited to the treatment group, which is where you were given financial literacy training, or the omitted category is 0, where it takes the value 0 is where you were not invited to the financial literacy training. And how does that affect insurance take up? So, what you have over here is this delta 1, the coefficient of interest. So, recall once again the regression framework that we discussed. The coefficient on the treatment indicator, in this case invited to training, reflects the average treatment effect when the conditional independence assumption is satisfied or randomization has gone well. And we have already checked that randomization has gone well, because the x naught i's are balanced across the treatment and the control groups. The only variable where it was not, it was significantly different, was the drought experience. And what you would do to account for that is to condition on drought experience. So, once you condition on drought experience, you know that invited to training is actually random or randomly assigned. So, in addition to invited to training, what the authors are also interested in is to see whether each of these or any of these marketing interventions that we have affects insurance take up. So, these combination XI essentially are the different marketing interventions that we discussed before, the demo, weather forecast and so on, and their combinations. So, all the 6 possible combinations. Right. So, the variable of interest is invited to training, which takes a value 1 if the farmer was invited to training, and takes a value 0 if the farmer was not invited to training, but belonged to the control group. And the combination x again is a dummy variable equal to 1 if the farmer was treated with that combination x. So, for instance, suppose combination x is a weather forecast, then if the farmer was given a weather forecast, then he belongs to the treatment group and the value is 1. If he was not given weather forecast, then the value is equal to 0, and so on and so forth for all the different x i's. So, what is the result? What they find is that when you just run the regression on invited to training, there is a coefficient of 0.053. Now, what does this mean? This means that about if you are invited to training, if you were given financial literacy training or assigned to financial literacy training, you have a 5% point increase in insurance take up. In the next columns, what you have is in column 2, you also introduce the 3 other marketing treatments: money back offer, weather forecast and demo. And what you find here is that there is not much of a difference in the invited to training coefficient when you include these other covariates or other treatments, and this is exactly what you would expect. Why? Because if invited to training has been randomly assigned, then you expect no other variable to have an impact or bias the estimates of this particular variable or bias these coefficients. The reason is because it was randomly assigned, it satisfies the conditional independence assumption and there is no selection bias. So, what you have estimated in column 1 is indeed the true parameter or the true effect of invitation to training, and if that is the true effect, it should not vary in the other columns where you include more and more covariates. Okay. So, it is an unbiased coefficient. So, once you include these 3 different marketing treatments, what you see is only the money back offer has some effect on insurance take up. None of the other 2 marketing treatments, demo and weather forecast, they do not have any impact on insurance take up. Similarly, when you include more covariates, which you found, remember in the previous when we were comparing the covariates across the treatment and control group, we found that each of these covariates were actually balanced across the treatment and control group. So, ideally they should not have any impact on your coefficient estimate, and that is what you find. The coefficient estimates hardly vary between the 3 columns. So, one more thing that the authors do is to understand whether this treatment effect, the average treatment effect that you see in the in this slide, which is about 0.05, whether that is same or homogeneous across the entire group of farmers that they have, or does it vary by the type of the farmer. So, what is the type that they are interested in? Over here they try to find out whether financial literacy training is more beneficial, let us say for people who have higher cognitive ability to begin with. So, it is possible, for instance, that people who have higher cognitive ability to start with, or maybe higher schooling, higher years of schooling, higher education to start with, maybe they benefit more from the financial literacy training because they understand more of what is going on in this in this financial literacy training. It could also vary by baseline literacy. So, for instance, you could imagine that people who have a very low financial literacy to begin with gain much more when they are imparted with the financial literacy education than people who had some knowledge of financial literacy to start with. Moreover, because different crops have different water requirements, insurance is likely to also have differential benefits for different crops. So, overall they want to look at heterogeneous treatment effects, and this is what they find. They find, so here what we have is we only they have in this particular table we only report the variable of interest which is invited to train. In the paper you will find the full table, but what is important is that the first column is essentially a replication of what you saw in the previous table, a 0.05 effect of invited to financial literacy training on insurance take up. But when you divide the sample by high cognitive ability and low cognitive ability in the baseline, this is even before the experiment started, what you find is that people with low cognitive ability actually are the ones who gain much more than the people with high cognitive ability. Similarly, when you go to levels of schooling initially, what you see is that people who have high schooling gain much more from financial literacy than people who have low schooling. However, so the same effect persists when you look at high financial literacy versus low financial literacy. So, what what the authors do in this case is they divide the data into subsets of of farmers with high financial literacy and farmers with low financial literacy, and within the group of people with high financial literacy, they would have a treatment, that is people who were invited to financial literacy training, and a control, people who were not invited to financial literacy training. And what they are looking at is the difference in treatment and control in insurance take up for this subset of high financial literacy group. So, this is high initial financial literacy levels, and what they find is that only this group benefits from the insurance from the financial literacy training program, but not the ones who have a very low initial level of financial literacy. However, one thing we need to account for in this table is the fact that we do not know whether the difference, this 0.068 and 0.041, whether these differences are significant or not. Okay. So, we need to take this with a pinch of salt though. Okay. So, to summarize what the authors find in this paper is that financial education has a positive and significant effect on rainfall insurance adoption. It increases adoption by 8 to 16% is what the authors measure in the paper, and the only marketing treatment is the money back guarantee intervention that has a consistent and large effect on farmers' purchase decisions. None of the other marketing treatments has any impact on the purchase decisions of this insurance, and what they show is that the effect of the money back guarantee program is actually comparable to price reduction of 60%. So, if you reduce the price of insurance products by 60%, then of course demand increases, and the extent to which demand increases when you reduce the price by 60% is equivalent to when you introduce the money back guarantee scheme, right. It increases demand by about 7% points. So, with this discussion of the paper on experiments, which was about marketing financial products, particularly a rainfall insurance product, we tried to understand how an experiment is designed, it is set up, and how what are the conditions that have to be met to get to the true parameter value. So, just to summarize what we learned in today's class is first that you have a definition, a theoretical definition of average treatment effect, where you are comparing the treatment and the control group and the outcomes in the treatment and the control group once the conditional independence assumption has been met, and that will give you the true treatment effect. Now, how you can use a regression framework to interpret the coefficient in a regression framework as the treatment effect, we tried to explain that, we understood that, and then finally what we were discussing is that when you actually institute an experiment, how do you ensure that this conditional independence assumption is met. So, what we discussed is that typically you would try to see if y naught I, which is basically the outcome variable that you are interested in, whether that is balanced across the treatment and the control group before the experiment has started. But in the situation where it is not possible to estimate y naught I, what you would do is you would measure x naught I, which is basically different other covariates between the treatment and the control group, and try to see if the treatment and the control groups are balanced across these various x naught i's on the various covariates. So, once you have validated the CIA assumption, the conditional independence assumption, you can go ahead and measure the difference between the treatment and control groups in the outcomes and see what the treatment effect is. So, that concludes our discussion for today, and in the next lecture we would take up more and we would see more about experiments and what are the things that could go wrong, and go from there. So, thanks all for attending today's lecture.